नमस्कार विद्यार्थी मित्र, मी सचिन पाटील. कॉम्पिटेटिव्ह पोटेन्शियल टू अचीव्ह सक्सेस या यूट्यूब चॅनलमध्ये आपलं सर्वांचं स्वागत करतो. आपण MPSC आणि UPSC मध्ये विचारला जाणारा मॅथ्स ऑप्शनल सब्जेक्टचा विचार करत आहोत. मॅथ्स या ऑप्शनल सब्जेक्टमध्ये 2 पेपर्स येतात, पेपर 1 आणि पेपर 2. पेपर 1 मध्ये 250 मार्क असतात, पेपर 2 मध्ये 250 मार्क असतात. पेपर 1 मध्ये आपल्याला ऑर्डिनरी डिफरन्शियल इक्वेशन हा एक टॉपिक बघायला मिळतो आणि तो टॉपिक जवळजवळ 40 ते 50 मार्क कॅरी करतो. So that it is a carry 20% weightage in a first paper. So it is the most important topic inside the paper number 1 of maths optional subject. So we are going with formulation of differential equation, first order, first degree differential equation, its type, integrating factor, the rules for finding the integrating factor. Those are the points which are covered in previous lectures, and right now we are going with the next point, which is a ordinary differential equation of first order but degree higher than 1. In previous lectures we had gone through we have went through different first order first degree differential equation. Right now we are going with the first order degree higher than 1. That means degree 2, degree 3, degree 4, and so on. Like that one, we are going with those differential equations in this topic here. Okay, for convenience, I am just taking dy by dx is equal to p is here. Okay, it is for convenience only. And general form of a first order, the general form of first order and nth degree differential equation is first order nth degree differential equation we are considered here, and which is nothing but a p raised to n plus p1 p raised to n minus 1 plus p2 p raised to n minus 2 plus and so on up to pn minus 1 pn minus 1 into p plus p is equal to 0. Okay, pn is equal to 0. Here p1 p2 p3 and so on up to pn are functions of x and y, and this equation, it is not directly solvable. It is not directly solvable, and it is a solve for particular conditions or particular cases, and those cases, special cases for which we solve differential equation, this differential equation especially, and those are the different types are nothing but solvable for phi, solvable for p only. That means we are talking about only p here. Okay, solvable for y, solvable for y, and third one solvable for x, and fourth one is, it is the most important thing, which is related with the what you can say, ordinary differential equation of first order and degree higher than 1, and this is the most important special case for the solving, and it is nothing but a Clairaut equation. This is the most important point inside this one. Those are the important, no doubt about that one. Solvable for p, solvable for y, solvable for x. But Clairaut equation, it is a special case which is having more importance in the MPSC and UPSC maths optional paper. paper number 1 is there. Okay, and according to, we are mostly concentrated on that Clairaut equation is there. Okay, so we are going with a solvable for P, solvable for Y, solvable for X, and so on. We first of all, we think about the solvable for P and how to solve the equation and how to solve example related with the solvable for P right now. Okay, we just take a minute. Once again, we consider the general form of first order and nth degree differential equation. Differential equation is, what is it? P raised to n plus P1 P raised to n minus 1 plus P2 P raised to n minus 2 plus and so on up to plus Pn minus 1 into P plus Pn is equal to 0. This is your nth degree differential equation of first order, because we know that P is equal to dy by dx is here. Okay, and sorry for that, P raised to n, and we resolve this equation in n linear factors like P minus a1, P minus a2, and so on up to P minus an is equal to 0. Here each factor is a first degree differential equation. So we equate each factor with 0. That means P minus a1 is equal to 0, P minus a2 is equal to 0, and so on up to P minus an is equal to 0. Okay, and find out the, we know that P is equal to dy by dx, therefore dy by dx is equal to a1, dy by dx is equal to a2, and so on up to dy by dx is equal to an is here. Okay, and then find out the what I can say, find out the solution for each differential equation which is related with x and y, and taking one constant related with it, and the solutions of each differential equation is, let us consider phi of xy c1 is equal to 0. Second, phi 2, let us consider phi 1, phi 2 xy c2 is equal to 0, and so on up to phi n x comma y cn is equal to 0. And this is the equation where c1, c2, c3 are the constants related with each differential equation, and combining these solutions related with each and every linear factor of that first order nth degree differential equation together, you will get the final result of the general solution of differential equation. That means this differential equation, first order nth degree differential equation, is phi 1 x comma y c1, phi 2 x comma y c2, and so on up to phi n x comma y cn is equal to 0. But we consider c1 is equal to c2 is equal to dot 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 cn is equal to c, then we get solution is phi 1 x comma y c, into phi 2 x comma y c, and so on up to phi n x comma y c is equal to 0. And this is your final result, or where c is the arbitrary constant related with that differential equation, and you will get the final general solution for that first order nth degree differential equation is here. According to that method, we solve the differential equation of first order and degree higher than 1 for particular p. That means p is nothing but a dy by dx. We are going with one example related with that, solvable for p is here. Okay, we solve this differential equation. P square plus 2xp minus 3x square is equal to 0, and it is solvable for p, and p is nothing but a dy by dx is here. So first of all, we have to find out the linear factor of that differential equation, and those linear factors are taken by using minus 3 having two factors, minus 1 and plus 3 is there, and according to that, minus into plus minus 1 into 3 is equal to 3, and these two factors having addition is equal to 2, and which is present here. And according to that, I'm taking factors are here p square, then minus xp plus 3xp minus 3x square is equal to 0. That means the addition of these two factors is nothing but a 2xp is there, and take grouping of these two parts and taking p outside from that one, p minus x is here, and plus 3x is taken outside from that, p minus x is also present here. Then p minus x taken common from these two factors or terms, and inside the another we will get the p minus x and p plus 3x is there. Then as per rule, these are the linear factors of that differential equation. It is a second order, it is a first order second degree differential equation, because higher index of that p is here 2, and therefore it is a first order second degree differential equation. So you will get the two linear factors which are nothing but a first order first degree differential equation, and considered p minus x is equal to 0, or p plus 3x is equal to 0. Right now p is equal to x, or p is equal to minus 3x is here, and p is nothing but a put p is equal to dy by dx is here. You will get the dy by dx is equal to x, or dy by dx is equal to minus 3x is here. Okay, then make a variable separable form is here, and dx is transferred to another side. You will get the dy by dy is equal to x into dx, and another one is dy is equal to minus 3x into dx. This is a variable separable form, and taking integration you will get the integration of dy, integration of x into dx, integration of dy, integration minus 3 is a constant taken outside from the integration, and this is the integration of x into dx, integration of dy is y, and integration of this is x square divided by 2, and plus c is the integration constant. Similarly, we are carried out here, y is equal to minus 3 x square divided by 2 plus c is here, and transfer those values or y on other side. You will get the x square divided by 2 minus y plus c is equal to 0, and I'm transferring this value here, and you will get the or whatever be there. I'm just taking y minus x square divided by 2 minus c is equal to 0, and y plus 3x square divided by 2 minus c is equal to 0. And these are the two solutions related with that linear factors, and we are taking combined equation related with it. You will get the final general solution. The general solution is y minus x square divided by 2 minus c into y plus 3x square divided by 2 minus c is equal to 0. And this is your final result solvable for p, having a second order differential equation is here. Okay, we are going with another example related with the solvable for p, and then we are going with the solvable for y is there. Okay, now we solve this differential equation, which is a first order third degree differential equation. Here we see that p is found everywhere and each term in the differential equation. So first of all, p is taken common, and here is square plus 2xp minus y square p minus 2xy square is equal to 0 is there. Then here taking a group of these two terms, and according to that, here p is a common, and therefore p plus 2x is there, minus y square is common, then inside the bracket p plus 2x is equal to 0. Okay, then this p plus 2x taken common, and you will get the p plus 2x, and inside the bracket p minus y square is equal to 0. Then according to rule, these are the linear factors of that first order higher degree differential equation. Then equate each linear factor to the 0. You will get the first order first degree differential equation, and which is solvable by using a variable separable homogeneous differential equation, non-homogeneous differential equation, a linear differential equation or Leibniz differential equation, then a Bernoulli differential equation, and Riccati differential equation, and Excite differential equation. Those are the different types of that first order first degree differential equation. According to that, we can solve these differential equations and find out the general solution for that first order third degree differential equation is here, and therefore p plus 2x is equal to 0, or p minus y square is equal to 0 is here. And according to that, sorry, okay, and here just a moment. Okay, that's all. I'm just going with the differential equations. Put p is equal to dy by dx is here, and according to that, dy by dx is equal to 0, or dy by dx is equal to minus 2x, and here dy by dx is equal to y square is here. And then variable separable form, you will get the just only dy is equal to 0, here dy is equal to minus 2x into dx, and here we transfer dx here and y square again here, and you will get the 1 divided by y square into dy is equal to dx is here, and this y square into dy. I am just taking the integration, taking integration of this, integration of dy is equal to, I am directly taking integration constant c is here, and then integration dy is equal to minus 2 is a constant and taken outside from the integration, and last one is 1 divided by integration 1 divided by y square into dy is equal to integration dx. Here also plus c and plus c are the integration constant related with it, and therefore y is equal to c, y is equal to minus 2 into x square divided by 2 plus c, and here we will get this y square is taken inside the numerator, and then taking the integration of this, you will get the final result. 2 to cancel to each other, y minus c is equal to 0. Then 2 to cancel, and you will get the minus x square plus c is here, and integration of this is nothing but a minus 2 plus 1 divided by minus 2 plus 1 is equal to x plus c is here, and y minus c is equal to 0. Y plus x square minus c is equal to 0 is here, and this is the minus 1. That means minus 1 divided by y is equal to x plus c is there. And we transfer this value, you will get the y minus c is equal to 0. Y plus x square minus c is equal to 0. And minus 1 divided by y minus x minus c is equal to 0. These are the three solutions of that linear factors which are present for the first order third degree differential equation having three linear factors, and you will get the three solutions of the first order first degree differential equations of that linear factors. And now taking it common, you will get the general solution, and the general solution is y minus c into y plus x square minus c into minus 1 divided by y minus x minus c is equal to 0. And this is your final result related with the we are also taking the minus common here, and making these factors or these terms are positive, and this minus sign transfer to another side, you will get the final result of that particular general solution is there. Okay, and according to that you will get the solvable for p, two different what you can say, two different first order higher degree differential equations. How to solve these differential equations, we perform two different examples related with the solvable for phi is there. We are just going with the solvable for y is there, and after that in next lecture we carry out the solvable for x and Clairaut equation is there, because it is the most important equation present inside the differential equation of first order and higher degree is there. Okay, now we are going with the second special case related with the first order and higher degree differential equation. Higher degree differential equation solvable for y is here, and according to that you have to take the first order differential equation. The first order differential equation, later to consider it is a f of x comma y comma p is equal to 0. That means it is an equation containing x, y and p. Those are the variables which are present inside the differential equation. P is nothing but a dy by dx is there, and we want to solve that differential equation. Later to consider solvable for y. Let y is equal to f of x comma p is there. X comma p is there. Then differentiating with respect to x. Differentiate with respect to x. You will get the dy by dx is equal to, first of all, dou f by dou x. Dou f by dou x plus dou f by dou p into dou p divided by dou x is here. Dou p divided by dou x is here, and dp divided by dx is here, because p is the function of x, and therefore you can directly carry out the derivative of p with respect to x is there, and according to you will get the dy by dx is equal to p is equal to dou f by dou x plus dou f by dou p into dp divided by dx is here, and according to that you will get the p is equal to pi of x comma p into dp by dx is there. That means it is a function of p is the function of x, p and dp by dx. and this is the first order equation in P, and solve it. This is the first order equation in P. After solving, you will get the phi of x comma y, x comma p comma c, x comma p comma c is equal to 0, and this is your final solution of that differential equation. It is a eliminating by p using equation. Later to consider it's equation 1. Equation 1 is here, and this is the equation later. Okay, it is equation 2, and equation 3 is here. Eliminating p by using equation 1 and 3, you will get the final solution or relation between x, y, and c is there, and this is the general solution of 1. What you can say, by using equation 1 and 3, eliminate p from equation, we get a relation between x comma p comma c, x comma y comma c, and this is general solution of equation 1. General solution of equation 1. Okay, here we are going with some remarks related with that solvable for y, and according to that you will get the some result related with a solvable for y is here. Okay, I'm just going with the one. Sometimes it is a very tedious job to eliminate the p by using equation 1 and 3. At that time we are going with a parametric equation. First we go with the parametric equation. X is equal to xpc, x of pc, and y is equal to y of y pc. These are the two equations, x and y, containing p as the parameter, and therefore it is a parametric equation. Parametric equations related with the solution, or treating as a p as a parameter is there. Then p is eliminated. Let it just a moment and just clear it. Okay, when p is eliminated, and solution may be the result between the variables and does not without any arbitrary constant. Okay, here when p is eliminated, and we get a relation between variables without any arbitrary constant, then it is called singular solution. And this is the most important thing, because a lot of time in a UPSC exam, singular solution, find out the singular solution related with the differential equation. This question arise in a different paper in UPSC examination. Okay, so it is a most important thing related with the differential equation. Singular solution is there, and this solution, when we are getting the equation which is in the form of a quadratic equation of p, and discriminant is equal to 0, then it is a p discriminant relation. Okay, what you can say, okay, if equation is a quadratic quadratic in P, then discriminant delta is equal to 0, then relation is called P discriminant. P discriminant. Okay, and if quadratic equation in C, similarly here quadratic equation in P, then quadratic equation in C, then it is delta is equal to discriminant is equal to 0, then it is called as a C discriminant. And this C discriminant relationship is nothing but a singular solution is there, and C discriminant, just a moment, yes, it is gives singular solution when quadratic equation in C and delta is equal to 0 and it gives the C discriminant relation, then it is a singular solution of that differential equation. And discriminant is nothing but according to quadratic equation, b square minus 4ac is equal to 0 is there. Okay, and this is the solvable for y. Here we take y is equal to f of xp, it is equation 1, and differentiating with respect to x, you will get the p is equal to phi of xp dp by dx, it is a second equation, and solving this differential equation for p, you will get the result of xp phi of xpc, and eliminating the p from these two equations, you will get the final solution, which is a relation between x, y, c. But sometimes it is a very tedious job. At that time we are going with a parametric equation, or p is eliminating, we get the relation of relation between the variables without any arbitrary constant, then it is called as a singular solution. And quadratic equation in P, then it is called as a P discriminant. Delta is equal to 0, then it is a P discriminant, and it is a general solution related with it. And if we get the quadratic equation in C and discriminant is equal to 0, then it is called as a C discriminant, and it is nothing but it gives the singular solution related with that differential equation. Okay, how it is works, we are going with one example related with the solvable for y is here. Okay, we solve it solving for y, we just take value of y, solving for y, that means this minus taken on other side as a plus 2yp is equal to xp square plus x is there, and then 2p is a multiply here, then it is a divide on other side, y is equal to xp square plus x divided by 2p is there, and once again I'm just taking y is equal to x common from that, p square plus 1 is here. Okay, p square plus 1 is here, and taking derivative with respect to x, then dy by dx is equal to here 2p is there, and therefore 1/2 is taken constant outside from the derivative, and taking the derivative by using a division rule, denominator as it is, and then taking the derivative of numerator x as it is, derivative of this is 2p into dp by dx, plus this is taken as it is, p square plus 1 into derivative of x is equal to 1 is here, and then taken minus numerator as it is, that means x into p square minus plus 1 into derivative of denominator, that means p having a derivative dp divided by dx is here, and then whole divided by square of that p, that means p square is here. Okay, and p square, this is divided by dx is nothing but a p, and therefore you will get the p square into p, that means p cube, and 2, that means 2p cube is equal to remaining term as right as it is, just multiply this p inside the bracket and you will get the 2p square x into dp divided by dx. Then multiply this p here, you will get the plus p cube plus p into this p square, that means p cube in plus p minus I am taking this one inside the bracket and you will get the minus p square x minus p square x into dp by dx is here, because this dp by dx also multiply here, and minus into plus minus x into 1 x into dp by dx is here, dp by dx. Then 2p cube is equal to 2p square x dp and minus p square x dp. That means you will get the only p square x into dp by dx. Then this plus p cube plus p minus x into dp by dx. This transfer, p cube transfer here and p also transfer here, you will get the 2p cube minus p, that means p cube, and minus p is here, and remaining term placed here, p square x into dp by dx minus x into dp by dx is here. Okay, and here p is taken common and p square minus 1 is here. Then here also x dp taken common, x dp divided by dx, and then inside the bracket p square minus 1 is here. Okay, and we transfer this term on other side, you will get the p square minus 1 minus x into dp by dx into p square minus 1 is equal to 0. Then here p square minus 1 is a common factor, and inside the another bracket p minus x into dp by dx is equal to 0. That means you will get the two cases. One is a p square minus 1 is equal to 0 and another is a p minus x into dp is equal to 0. I am taking the first case here, and first case 1, I am just taking the p minus x into dp divided by dx is equal to 0. This is a p is equal to x into dp divided by dx, x into dp divided by dx. Then transfer the x and dx here, you will get the dx divided by x is equal to dp divided by p is there. And taking the integration of this, I'm just talking about the integration of that particular, just a moment. Okay, taking the integration on both sides, integrating, you will get the integration of this is a log x, integration of this is a log p, and I am taking the log c is here. Okay, and this is minus plus, and okay, no problem. Just we take p into c, and we will get the value of, okay, I'm taking it reversely. First of all, take the integration of this is a log p, and then log x plus log c, and therefore p is equal to xc, and putting this value p is equal to xc in equation 1, this is equation 1, and you will get the result of that, and this result is here. Put p is equal to xc in 1, here x into p is equal to xc, that means x square into c square minus 2 into y into xc plus x is equal to 0, and that means it is a x cube c square minus 2xyc plus x is equal to 0, and this is your final result which containing the C, that means it is a general solution of that one. Right now we are going with the case number 2, which is related with a p square minus 1 is here. I think you will get the complete solution related with the solvable for y. For this purpose we have to find out the value of y is here, and derivative with respect to x. You will get the equation, and this equation containing these two factors. First factor is a p minus x into dp divided by dx. We solve it, we will get the general solution for that differential equation. Right now we are going with a p square minus 1 is equal to 0, and then find out the what is the equation solution we will get for that one. Okay, and according to that, case number 2 is here. P square is equal to p square is equal to, yes, p square is equal to 1 is here, and p is equal to plus minus 1, and putting this value put in 1. What is the equation 1? 1 is a equation, I'm just taking from here. Equation 1, what is the equation 1? Equation 1 is a xp square plus minus 2yp plus x is equal to 0. Putting the value of p is equal to plus minus 1 inside this, and you will get the result of this equation is nothing but what? I'm just taking the p is equal to plus minus 1. Plus minus 1 square is equal to 1, and therefore it is a x minus 2 into y, and a plus minus 1 is here, plus x is equal to 0, and therefore you will get the x plus minus 2y plus x is equal to 0, and just taking one, x plus 2y plus x is equal to 0, or x minus 2y plus x is equal to 0. Then 2x plus 2y is equal to 0, or 2x minus 2y is equal to 0. 2 is common, and therefore x plus y is equal to 0, or x minus y is equal to 0. And these two equation does not contain any arbitrary constant, therefore this is a singular solution of that differential equation. As per that, you are getting the complete idea related with the first order but the higher degree equation, which is solvable for p and solvable for y is here. In the next lecture we are going with a solvable for x and solvable Clairaut's equation, and Clairaut's equation is most important equation inside this, and according to that you have to find out the solutions, general solutions and singular solution for the differential equation for solvable for y is here. जर तुम्हाला हे आवडलं असेल तर लाईक करा, शेअर करा आणि सबस्क्राईब करायला विसरू नका. थँक्यू.